Hell yeah.
Okay, so return of the Dino Zoom. It's not much of a Dino Zoom this time, though. I'm not going to lie to you. It is a bit more of a life on Earth Zoom. And so that's kind of why I picked this one. You can see all these other crazy critters in addition to the dinosaurs, which this guy should definitely, by the way, be covered in feathers. And this guy should have some prickles maybe on the back of their tail, but you know, still a cool drawing. So,
is that Cadillac Dinosaurs or no?
It's not from Cadillacs and Dinosaurs. No, this is this guy named Ray Troll, and this is an older thing, so we'll let it pass. But he actually does dinosaur music in addition to his own dinosaur art, like prehistoric music and stuff. So anyway, overview. So this is gonna be a review, but welcome back, everybody. We're doing it. And big idea is that, like, if you take nothing away from tonight, just know that life has been on Earth for a very, 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 very long time. For like the thing I always say that a lot of people know if you came last year, but is that we live closer in time to Tyrannosaurus Rex than Tyrannosaurus Rex did to Stegosaurus. So it's been a long time with a lot of stuff, and we are just this little sliver on the end of things. And not everything here I say tonight, a lot of stuff is changing constantly. Even some stuff I said last year is now changed, partially because I just screwed up, but also because they're just constantly finding new things to learn about. So paleontology, even though it's about old things, it's a always changing field. And it's gonna get weird. You guys picked some weird things. So there's gonna be some weird creatures in here, some real weird tangents, but that's the way it goes.
I hope you're not the weirdest part of this. I hope the rest of us get very weird.
It's gonna get weird, trust me. It's gonna even start kind of weird. And of course,
accomplished.
It wouldn't be a Zoom without me saying, oh, by the way, there's an Eons video about this. Eons, for those who don't know, is a YouTube channel run by PBS that does really, really great prehistoric videos about prehistoric life. So if we have a slide that has something, I'm like, if you want to know more about this, you can check out the Eons alert, and I will send you guys probably tomorrow, realistically, a list of all the Eons videos that if you were like, I really like that thing, what was that about? You can go and actually watch that video. So some basics. So this is a little more than what we did last year, but there are different scales of time scientists use to break things down. There are eons, which are these giant levels of time. Then there are eras, Paleozoic, Mesozoic, Cenozoic. There are periods, and then there are epochs. And then below epochs are ages, which aren't even on here. So we're actually going to kind of jump between these a bit, but remember that it kind of goes eons, eras, periods, epochs, ages. Last year, we started with the Paleozoic and kind of blasted through everything. We're actually going to start all the way at the beginning this time. So strap in. Another real little thing that I kind of talked about last time, but I'm going to get into it more, is that Tyrannosaurus Rex is the genus and species, just like Homo sapiens. For a lot of things here, I will just kind of say the genus, but in some cases I'll talk about the species, and sometimes I'll say, oh, there's different species. Also, scientists are always fighting about what actually is a species versus what's a genus versus sometimes all those different things. They're always arguing over that. They argue about that with animals today, but they even argue about it. So if you can imagine they're arguing about animals alive today, they're going to obviously be arguing about it when all they have is a bunch of bones to figure out. So anyway, that's a thing. And then so we all remember, maybe even remember kingdom, phylum, class, all that stuff, ordered, family, genus, species. That's really helpful for us today. But when you look at things through deep time, they often use this phrase called clade to split things up, which just means all these animals share a common ancestor and then boom, pop out that way. So it's a way of just kind of continuing to split things up a bunch of times because nature is actually pretty messy. It doesn't fit into all these easy categories. And like the example I always give that maybe you remember from last year is that reptile makes sense for us today because a reptile is a scaly thing that breathes air, that walks on land, that lays hard eggs. But birds and crocodiles in a lot of ways are actually more closely related to each other than crocodiles are to lizards and snakes and turtles. So it's just, that's why we're gonna, don't worry about it. Anyway, moving on. we're going to start with the Hadean eon, and that means hell, basically, Hades. And this is the beginning of the Earth. It was 4.6 to 4.4 billion years ago, and it was just molten ash and rock and everything. Planet was just forming. Our moon probably formed when some big asteroid smacked to the Earth, and then that got caught in the orbit and everything, but wasn't a good place to be. But then we moved into the Archean eon, the Archean eon, which means beginning. This is 4 to 2.5 billion years ago. And you can kind of see these little interesting rocky things down here, which we're going to talk about in just a second. Those are called stromatolites. And stromatolites are sedimentary formations created from photosynthetic cyanobacteria. So if you go down to Australia, you can see these, and they are the oldest fossils on the planet we can find. Now, it doesn't mean that they showed up in Australia first. It just means that that's where they are. Those are the ones that are left. But basically, it's just all the cyanobacteria that squished and fossilized and became these rocks. Western Australia has the oldest ones, 3.5 billion years old. And they were made from anaerobic prokaryotes, which just means basically tiny little cells, early cells without really anything inside of them that did not need oxygen. And it's possible that this actually happened even earlier than where these come from, even back, at the end of the Hadean. They found stuff called biogenic carbon. It's a little complicated, but there's a whole eons video about it if you want to check it out. And then, does anybody know, feel free to jump in, what panspermia is? Nope, okay. Panspermia is, wait, David does. I know David would.
It's like the galactic life spreading through like comets and asteroids and stuff, right?
Right, so there's also
sperm. It's sperm for everybody.
Yes.
That's what I got out of it.
It's basically means that the seeds could have come from everywhere. Who knows, right? It means that maybe life didn't originate on this planet. Maybe it hitched a ride on an asteroid and smashed into the Earth, and that's how the first cells started. Like, who knows? There's that theory too. So anyway, then we move from the oh my God, I forgot, shit. The Archean eon. Okay, so we're in the Proterozoic eon. This is the old life, the former life. And this is 2.5 billion to 541 million years ago. And the first eukaryotes and multicellular life appear. So a eukaryote is like this guy here. He or she has a bunch of little thingies in it, little tiny organelles, little mitochondria and whatever. So the cells start to get a little more advanced. In the middle of this whole thing, there's a thing called the Great Oxidation Event. It was 2.4 billion years ago. Oxygen became a real problem because suddenly all these cells showed up that were, expelling oxygen, which had never really been on our planet before because they were prokaryotic, or because they were anaerobic. So that actually caused. So right now we have too much carbon dioxide. What's happening to our planet with too much carbon dioxide? Anybody?
Climate change.
Global warming, right? That's getting too warm. So if you expel way too much oxygen in the atmosphere, what happens?
Cold.
It gets way too cold, right? So we had this Huronian glaciation where the entire planet got covered in ice for 300 million years. But that was actually pretty good because it gave us the ozone layer, which was very helpful for life to continue. And it set the stage for multicellular life because it needed it. So there's a whole eons.
There was no ozone layer before this?
No.
What? Okay.
Was that political or why?
What do you mean? The ozone?
Yeah, who chose to not have that?
Nobody chose it. That's not how life works, Max. Anyway, so there's a whole eons video about the Great Oxidation Event. It's really interesting. But anyway, we'll move on from there. So then there was this one ice age that the Earth got covered in ice. And then from 720 to 635 million years ago, there's another period within this thing called the Cryogenian. And there are actually two ice ages within it, the Sturtian and the Marinoan. And they don't exactly know why this one was caused, but it was maybe the breakup of Rodinia, which was another supercontinent before Pangaea. There's a whole other supercontinent before Pangaea that broke apart. And in doing that, there were all these basalt and sulfur eruptions that covered the world in ice again. And there's another Eons video about that.
Are we supposed to take a shot every time there's an Eons alert?
You would die. You two might.
Yes, Max just went to make drinks. That's what we're about to do.
Yes. So it's also possible, though, that sponges, which were like the first kind of pretty advanced life, were the ones that saved the day by kind of breaking down all this oxygen and taking it out of the water and everything, and kind of helping then balance things out again so that the ice all melted. I just put it there. Sponges ate the cyanobacteria and they made room for algae, and algae expel CO2 and all helped balance things out. And the oceans became oxygenated again. And that led us to the Ediacaran, which is kind of this interesting time where I always talked about the Cambrian explosion, which is coming up, but this is later on at the end of the Proterozoic. There might have been another little explosion called the Avalon explosion. So it was like really, really early life and stuff, but it was this whole other weird period where there were just these weird little things that you see here.
Take a shot.
And that's right, yes. And then there was maybe, though, a little mass extinction called the end Ediacaran extinction. The thing is, we're so far back in time right now that they just really have a hard time figuring out exactly what was going on. But anyway, that's the Ediacaran. So we move from the Ediacaran into the Phanerozoic Eon. So now everything else, we've done all the other eons, and now we're just going to be in the Phanerozoic Eon the whole time. And within the Phanerozoic Eon, we're going to do the Paleozoic era. So Phanerozoic means visible life, because it's a life we can see now, and Paleozoic means ancient life. So my favorite thing ever, the Cambrian explosion. If I ever have a band, I'm calling it the Cambrian explosion, but it's this time when life just went bananas and boom, all this crazy life appeared. You got all these cool things started showing up at a very rapid rate, 541 to 45 million years ago. Complex multicellular life, early arthropods, which are animals with joints like insects. And I mean, insects didn't show up yet, but things with jointed appendages and stuff, bivalves, which are clams, cephalopods, which are like squids and octopi, and even the first very, very, very early vertebrates, which are things like us. But was it really an explosion? There's a lot of debate now that maybe it wasn't as much of an explosion as we think. And the other really interesting idea is if there was an extinction at the end of the Ediacaran, perhaps why there was an explosion was just because nothing was alive and all these new animals came and filled up all the empty niches. So there's a whole eons about it. Check it out. So this, I don't think Sarah could be here. I think she just is getting over shot number 2. But this was her pick, which is a hallucigenia, which is this weird little thing. It is an early ancestor of velvet worms. And when they first found it, they actually put it upside down and they thought it was like the finger of something else. They didn't even know what the hell it was. So anyway, but they figured it out. And now, this is David's pick. They also were the first tardigrades. And I got this wrong last year. I said tardigrades didn't show up until the Cretaceous, but I was wrong. The ancestors of tardigrades actually show up all the way back in the Cambrian, but in the Cretaceous is when we get the ones that look like the ones we have today. So I was wrong about tardigrades. And I mean, I feel like everybody here kind of knows the deal with tardigrades, but they can kind of survive anything. They've taken them to space. They can really just survive intense pressure, intense heat, intense radiation, and all this stuff. But people are always like, they're invincible, but really, if you picked up a tardigrade, you could squish it with your fingers. So it's not like they're invincible, but they are really neat. So moving from that, we go into the Ordovician.
And is there a reason that the last one was called the hallucigenia?
It means like hallucinating because it was so weird looking. They didn't know what it was. So it's like, okay. Oh my God, what's that? Hallucigenia. I'm hallucinating. I can't figure it out. Yeah. That's what it means.
That's why I'm a little disappointed about that answer.
Sorry, guys. So then the Ordovician, 45 to 444 million years ago. We get early fish. We get more cephalopods. We already, more advanced cephalopods, coral, and the very first insects. You also get, in this picture, we have some other cool things that I'm just going to point out. We get eurypterids, which are these sea scorpions, which are super badass. And you get, of course, my favorite little trilobites, one of which will forever be emblazoned on my back because of the tattoo I have. But this ends with the Earth's first mass extinction, which is possibly caused by early plants, kind of screwing everything up with just being plants. And the world was like, what are plants? And I changed the chemistry of everything. So I have fruit snacks. These are dinosaur fruit snacks, but we're going to pretend that they're Ordovician creatures right now. I'm going to eat. I am the forces of nature. I'm going to eat and make these fruit snacks extinct every time we have a mass extinction. So.
You're just eating fruit snacks when there's a mass extinction?
Yes.
Take a shot.
I'm taking a shot. I'm drinking too, Max.
You should have a Jello shot. You should have Jello shots.
I should have Jello shots, but I don't have any Jello, Max or Brian. Don't worry, I'll get there, man.
You're gonna be on such a sugar high, and I can't wait for the end of it.
Right, I gotta keep my energy up. This is a lot to go through. So this was. Oh, go ahead. Go ahead, Colin.
That's the only way you're going to get us in shorter than last time, is if you get so hyped up on sugar.
Oh, Colin, I don't think it's going to happen.
Let's do it, bud.
All right, we gotta go. We gotta go. Okay, we got embryophytes. This was Meta's pick, and embryophytes are now they're actually probably what's called a paraphyletic group. That means they aren't actually all that related to each other. They're just so monophyletic means these things all share a common ancestor. Paraphyletic means we're kind of cheating here, like we're just using it because it's convenient for us. So, but the first embryophytes, which are the first plants, do show up in the Ordovician. True mosses are known for the Carboniferous, but maybe early in the Silurian. You don't have to worry about this, but moss ancestors show up in the Ordovician. Liverworts, which are these ones in the middle, they go back all the way. They definitely go back to the Ordovician. And hornworts are actually only known from the Cretaceous, but there's possibly Devonian ancestors, which is like so far apart. It's like, what is even going on here? And basically it's like, well, guess what? Mosses are like, they're like embryophytes, not mosses, they're really hard to fossilize. We're looking really back into deep time. So they really don't know the details on these guys. But we also get taxites from 470 to 360 million years ago, which are giant fungi nearly 30 feet tall. So this is what was happening on the surface of the planet. And it's also possible they weren't fungi, but even a lichen, which means that it's a fungus having a symbiotic relationship with an algae. So it's possible also fungi coming across the Earth helped out those early plants, like they do today with all their mycelium and stuff like that. And then, but specifically prototaxites possibly were outcompeted by more advanced plants later on in the Devonian. And there's a whole eons about prototaxites if you want to read about them or learn about them. So now we're in the Silurian period. It's not the aliens from Doctor Who. 444 to 419. The fish diversify, we get arachnids, we get more fungi, and the centipedes even go onto land. And we didn't have anything specific for the Silurians. We just move on to the Devonian. 419 to 359, the fish diversify, the first tetrapods appear, and there's eons about those, and the trilobites decline. Now, tetrapods are basically, we are all tetrapods. Tetrapods are creatures that crawled on the land and didn't decide, but like started living on land. And not insects. Insects came to land first, but basically vertebrates, things that are not fish, but vertebrates. Plants really start taking a strong hold on the land. They get root systems. We get the first horsetails. We get the ferns. We get the first trees. There's a whole eons about it. You should check it out. And it ends with, oh my God, Earth's second mass extinction, possibly because the plants took all the CO2 away from the atmosphere and kind of screwed everything up. But we're going to talk about ammonites 409 to 65 million years ago. So ammonites are these guys. They're basically squids with shells. They're more closely to octopi, squids, and cuttlefish than nautiloids, which are still around today. So even though nautiloids look a lot like ammonites, they're not actually that closely related. But ammonites did really, really well. They lasted all the way to the dinosaur extinction, and they were all over the place. And ammonites grow fast. They had lots of offspring. That's part of why they were so successful. They lasted no rotations. I already said that. And there's eons about them. Check them out. Okay. Now we have, I got a gummy in my mouth. Okay. We have Dunkleosteus, which is 382, 358 million years ago. It was a giant placoderm, which means a plate-skinned fish. There's a group of plate-skinned fish that had like plates all over their body and everything. It was pretty damn big. It was 29 feet long. And it didn't have teeth, but it had sharpened armor at the front of its face.
Was this mine, Dan?
I think so. Yeah.
I think so.
Yeah. And it depends on who you ask, but it was definitely among the strongest bites of any animal ever. It was pretty much, it's this guy, it's T-Rex, and it's like the really big alligators. And maybe Megalodon. They're always like, it's one of these guys, but it's in the running. It's in the conversation. And we know they bit each other too, because we find other Dunkleosteus with like giant bite marks from each other. So pretty badass. And there's an eons about them. Check them out. This is why you should not take a shot for every.
Definitely take a shot every time there's an eons alert.
This guy had the best bites.
Is this a D&D thing that we're doing? I'm getting late.
Yes, Max.
Looks like a monster.
Yeah, these are all just D&D monsters.
Oh, cool. Great. Thank you.
Right, then we move into Carboniferous. 359 to 299 million years ago. There were large, hot, swampy forests everywhere. The first amniotes appear. Does anybody remember who was here last year what an amniote is? Nobody does. Okay. An amniote means a hard-shelled egg. So up to this time, we had stuff crawling around, but they all had to lay their eggs in the water. And this is when the first animals were like, I can lay an egg. I realized I am not watching the chat at all. I apologize for that. If people are chatting me, I can't see it. And I don't know how to make that work. So if you have a question, do jump in. I'm sorry. I apologize now. But and we get the first. Go ahead.
Swallow the gummies.
I'm going to. We got Brian. You don't know how long we have to go. And we get the first synapsids. And so synapsids are one group of reptiles that have, it's basically just known for certain openings in their skull, but they're a whole different diverse group of reptiles, many of which are still around today. This was Jody's pick. This was Meganeura, which was 305 to 299 million years ago. It was a huge dragonfly with an over 2-foot wingspan. And so what happened was, in this time, there was really high oxygen content and not very many predators. So it meant lots and lots and lots of big arthropods, which are, so you had giant millipedes, you had giant dragonflies, you had all these huge insects flying around all over the world.
No, nuh-uh.
Yeah, so, but there's a whole eons about it. Then we move into the Permian. And so we get some gorgonopsids are over here, which are one of my favorite creatures, but we didn't actually go into them. So these are, actually this helps, we'll get into this, but I said synapsids, this is probably a synapsid. It's a Lystrosaurus, I believe. This is probably a synapsid, but this is actually a diapsid. And you don't have to worry about that much, but that's kind of the two branches that reptiles took.
Sorry, you've just said 1,000 words I don't understand.
It's okay.
What is a synapsid and what is a diapsid?
And a gorgonopsid.
And a gorgonopsid.
A gorgonopsid, I know, I'm sorry. Gorgonopsid is just a group of mammal-like reptiles that are more closely related to us than they are to like lizards. They are a type of synapsid. And we are synapsids. We are descended from synapsids. whereas the diaps, they switch it. The diapsids are the group that led to dinosaurs eventually, and also lizards and snakes and things like that. Also in the Permian, Pangea takes form. There's these vast inland deserts, and diapsids and synapsids flourish. They really do well. These two groups of reptiles just go all over the place, are taking over everything. And conifers dominate, the first commoners. Oh, and this is Anna. I don't know if Anna made it. This is Anna's pick. Feel free to chime in. What do you guys think this is?
What
That's for sure a shell.
is that? A chambered nautilus? Or something like a chambered nautilus?
Like
I don't
a
know.
conch?
I have one of those somewhere.
Oh, no.
Ooh.
Yeah, that's Jeff.
Is it a giant?
Whale.
Jeff.
It's a whale?
Jeff.
Interesting.
Way too early for whales.
What's the nautilus shaped Pokemon? Isn't that the one?
Oh, that's
it's a Pokemon.
Yeah, it's
It's not an Omastar. All right.
Doug trio. It's a Doug trio.
It's not
Right,
There you go.
obviously.
There you go. It's a,
All right, we're gonna move. We gotta go. It's not any of those things. This is from Helicoprion, sorry, which they didn't know what it was when they first found it either. They thought it was its teeth from some weird shark, and they didn't know how to make it.
What in the hell is that?
They thought it looked like this. Then they were like, no, that's silly.
Wait, can it retract, or like, what's the advantage?
No, it's
if
hard.
doesn't-
It's hard. They didn't. Hang on.
Can it
Can
just
it
like
fly?
a mallet to like?
They didn't know. This is how they first reconstructed. They thought maybe it dug around in the ground with its weird teeth. They didn't know what the hell it was. Then they were like, "This is too silly. This isn't it. This doesn't look anything like it. It must be this." And then they
Oh
were
my
like,
God, you made it worse.
and then they were like,
That's
"That's
any better.
obviously that's Helicoprion right there."
It's
There-
better.
Obviously, that makes
It's better.
more sense.
So the thing is with sharks, when they find fossil sharks, this is how it is with Megalodon too. They don't, all they find is the teeth. They don't find the cartilage skeleton because it's cartilaginous. So they always had to guess because they found these weird ass teeth that didn't know what to do. And finally they were like, no, it looks like this, which is better, but still pretty weird looking.
Like it's a saw, like a.
Yeah. So that's Helicoprion. And it was 270 million years ago. It's not a true shark, but closely related to sharks. And they don't really know how it ate. They don't really know what it did, but they think maybe it like ate soft body play with squid, or like was an ammonite shucker. So it like grab the ammonite with its lower teeth and then slurp them out or something. But it was a weird ass animal. And there's an eons about it. Check it out. And now we come to the great dying, which means I gotta eat some fruit snacks again. This was the worst extinction of all time. The dinosaur extinction was bad. This was way worse. 96% of all marine species go extinct, and 70% of all terrestrial species go extinct. It's real bad deal.
Fuck yeah, terrestrial species.
I mean, yeah, I guess we came out on top, but it was not great. They really don't know what did it. They think maybe an extraterrestrial impact, maybe a bunch of methane got released from the seafloor and screwed up the climate, or maybe it was increased volcanism, more volcanoes, because Pangea was starting to kind of break up and that would have caused some more volcanoes. But there's a whole eons about it if you want to check it out.
Wait, when was this?
This was at the end of the Permian. So I will find out when I see the next slide, because I don't remember it's
It's
exactly.
like 2005
Let's say
million.
250-ish,
Oh, yeah.
years, I want to say, is the end of Permian into Permo-Triassic extinction. This is a bad one. But yeah, 252, there you go. But that leads to the Mesozoic era, which means middle life, and is obviously the best one. There's a whole eons about the Mesozoic if you want to check it out, just the basics. So you guys should all know by now, maybe, that there are 3 periods within the Mesozoic: the Triassic, the Jurassic, and the Cretaceous. And this is the Triassic. We did this last year, so I'm gonna kind of go quick. But here's kind of what the world looked like. So it's Pangea, but it is starting to break apart a little bit. And I'll do these quickly, but at first it was very empty because there was not anything, like nothing made it through that extinction. So like it was only like a handful of animals, like there was very low biodiversity in terms of species around. And their own, yeah. And then, but we did get conifers and cycadophytes, which are gymnosperms, the first seed plants. And the archosaurs became a successful group, which is a group that includes crocodiles, dinosaurs, and others. And archosaurs had air sacs in their bones that helped them kind of move around. Even crocs have those. They're actually more active than other reptiles. They're able to move quicker and faster and be a little more active. And there's eons about that. And we get the first ichthyosaurs, which are like fish lizards. We get the first plesiosaurs, which is like the Loch Ness Monster. And we get the first pterosaurs, which are like pterodactyls. But there's a whole, the pterodactyl is not just one, there's a whole group of pterodactyls. I should be eating my gummy things, by the way. We had a mass extinction, and I forgot.
Sorry, you said that there was a plesiosaur and then said like the Loch Ness Monster.
The Loch Ness Monster is not real, but is basically a plesiosaur. We're gonna, yeah, you'll see, Max. And we get the first testudines, which are turtles. And there's a whole eons about turtles, but Jess, don't worry, I put in a lot of turtles in here, so you're gonna see a lot of turtles.
Great.
So I really like the Triassic because it kind of gets ignored. It doesn't have a lot of dinosaurs in it, but it's also this interesting time where reptiles were kind of experimenting and trying all these different things. There was no guarantee dinosaurs were going to make it, but you know, it's just this neat time where nature's really experimenting. I mean, there's this giant extinction, and then the Triassic is kind of like trying to figure out what's going to happen. This was Alex Cardullo's pick. This is Charopteryx. I told you it's going to get weird. 225 million years ago. It's an early archosaur. It's not quite a dinosaur, but it's an archosaur. I think, was it Alex and Jack picked Longus last year? So that was also an archosaur that was not quite a dinosaur. It's the only glider of all time where the membrane goes around its pelvis, its back legs, rather than the front legs, which makes sense because it looks really silly. So that's Charopteryx. That's all I have on it, actually. And of course, in the Triassic, we get the first dinosaurs. This is an early dinosaur.
Dan, nobody cares about dinosaurs. Move on.
Raptors, move on. Who cares? Sorry, nope, we're talking about dinosaurs. So, dinosaurs, I did this last time, but they kind of split into two different groups. We have Ornithischia and Saurischia. You don't have to worry about it, but it's based on the structure of their hip bones. So, and even this is still being debated, although I'm still kind of stuck with what they say here, but there is some debate still happening about this. And oh no, there's an extinction at the end of the Jurassic, possibly because Pangea was breaking up some more. But this is what allowed the dinosaurs to radiate out, is because all these other reptiles were there and dinosaurs were kind of the shadows, but the dinosaurs were small and quick and fast at the time. And so that really allowed them to be the successors. So really I should have another thing of fruit snacks right now, but I'm just gonna have to keep going. So we're gonna go into the Jurassic. These are, I'm actually doing okay on time. Okay, I'm doing great. So the Jurassic is a very typical Jurassic scene. You have these long-necked sauropods with these long necks to reach high up in these giant forests everywhere. But if you look closely, you can see what looks like a Stegosaurus down here. You're also seeing some of the first ornithopods. So you really start to, things really start to look like what you think about when you see dinosaurs, when you think of dinosaurs. But I do like that these guys, they gave them some weird feathery faces, because we don't know, maybe, why not? So here's the Jurassic. You're sort of getting this northern continent and the southern continent. The northern continent is called Laurasia. The southern continent is called Gondwana. You don't have to worry about that, but in the Jurassic, the dinosaurs diversify, conifers dominate. It looks a lot of the world just looks like Northern California and the Oregon coast. The true squamates appear, which are true lizards. We have lots of lizard-like things, but actual true lizards appear. And we get probably the first true mammals. We had a lot of mammal-like things back in the Triassic. Probably get the first, it's debatable, but we get things that really are true mammals. So this is Logan's pick. This is Cinomacrops. This is a very new one that they found recently.
Where did you get these images from? These are like really detailed high-res images.
It's just the internet, man. This is what I do, but I did.
Time travel.
Mm-hmm. This is an anurognathed pterosaur from China. That's just a certain group of pterosaurs that all kind of look like this. but they think it was probably a nocturnal insect eater because it has these giant eyes, and it wasn't very big. It was really quite small. And that's it. That's Cinemacrops. So we're going to briefly, so Cinemacrops, by the way, is a pterosaur, not a dinosaur, but would be an archosaur because archosaurs contain pterosaurs. Now we're going to talk about the sauropods, which are the long-necked dinosaurs. Why are they so big? We don't exactly know. It's just a weird defense, but like honestly, to this day, paleontologists are constantly debating about how the hell these animals survived. They were crazy, but they were clearly around the whole time, so they clearly did something right. But it's like insane that these things were able to like feed themselves and, you know, even like pump blood up their necks and all this stuff like that. Like they're crazy. And here is Mamenchisaurus, which is one of a very good sauropod. It lived in the Jurassic from China, although there's some debate about maybe they found some fossils of it in the Cretaceous too. Its neck was over half its own body length. It's crazy long neck. And it was 49 to 85 feet, possibly up to 150. They found one weird specimen that was maybe 115 feet long. So it was a pretty long dinosaur. And now we're going to talk about theropods. So these are both the Saurischia side of things, sauropods and theropods. Theropods are just things that look like T-Rex or raptors, basically, is what you need to know. Probably all of them had feathers somewhere on their lineage. Maybe the certain ones lost feathers later on, but at some point in their history, they probably all had feathers, more or less. So this is Amanda's pick. This is a really cool pick, actually, Amanda. This is Lemusaurus, which is a theropod from China. Same time period as both, actually, the last two creatures we had, as Mamenchisaurus and as Cinemacrops. The juveniles were toothed, which they lost their teeth as they got older. So, you know, we are definitely finding that dinosaurs really changed their look as they grew up, but this is without question the one that changed the most that they found so far. The babies had teeth and then they completely lost their teeth and looked like a different thing.
Dan, I'm sorry, the photo that you chose does not make them look nearly as fucking weird as the ones that I found.
They're pretty weird. I mean,
they look so weird.
They're pretty weird. Well, here's the thing. So they know that they started out eating insects and stuff as they were little. And then as an adult, they ate plants. And they know that because they found gastroliths in their belly, which is what birds do today, where they ate a bunch of little rocks to grind up their food. But it looks like a herbivore, but it's actually a ceratosaur. So it's on the same line as all those toothy theropods. So it's a theropod that had teeth as a kid and then lost their teeth and became a herbivore. It was a real weird dinosaur. They think it lived in groups because they found them in groups together. And part of that is because they found them in these death pits that were probably Mamenchisaurus tracks. So they found that some of them had died in tracks of the Mamenchisaurus you saw in the last slide. So that's Lemusaurus. Now we have Dacosaurus, which is not, actually, what do you guys think? I want you guys to tell me. What do you guys think this is? Where does it belong? What kind of creature is it? What's it related to? Anybody? Nobody wants to guess.
Archosaur.
It is an archosaur.
Then I win.
Dan,
Okay.
a lot of people are talking in the chat.
Oh no, I can't see the chat. How do I see the damn chat?
What's the question?
They're saying like alligator, whale, eel.
Okay, so some people said alligator, and that is correct. This is a marine alligator that adopted a completely underwater life. And it's part of the Metriorhynchids, excuse me, which lived from 170 to 135 million years ago, which means they made it into the middle of the Cretaceous and then died out. So some of their adaptations to let them be good for water was completely smooth skin. They had a light skeleton. They had salt glands to help them expel water. And they had a compact inner ear so they could hear better underwater too. And also so they could dive and not have to deal with like water pressure and stuff. And they likely gave live birth at sea. So they were crocodiles that basically became whale things. And there's a whole eons about them. Check it out.
Take a shot.
Now we're back to dinosaurs. These are the thyreophorans. And these are armored dinosaurs. That's kind of split into two groups. Got the stegosaurs and the ankylosaurs. So now we're on the ornithischia side of things. They're armored dinosaurs. And on the other side, the ornithischian side of things, you have the ornithopods, which are these kind of just duck-billed creatures. And so now we're moving from the Jurassic into the Cretaceous, and the world does change. It's not considered extinction, but tell me, what do you guys think about what can you tell by just looking at this? These are dinosaurs from the Jurassic. These are dinosaurs from the Cretaceous. What do you guys notice?
Jurassic's bigger.
The necks got smaller.
Yeah, the necks got smaller, which to me implies less herbivorous, more carnivorous.
You guys
I also noticed it's not currently considered a major extinction event.
That's correct, Brian. Very good. Where'd you come up with that? So, yes, there was a transition. Basically, angiosperms, which are flowering plants, started showing up in the Cretaceous. And when these giant sauropods came and raised a whole giant towering forest, angiosperms are better, just like after a forest fire or something, smaller flowering plants are better at taking over quicker. So those sorts of environments started to change, which meant a lot of the dinosaurs that were more adapted to eat those sort of things started being successful. So the world kind of changed. That's why we wound up getting less sauropods and more of these other kind of animals. Maybe, that's all up for debate. But anyway, here's the Cretaceous period. We're moving into the Cretaceous now. And the continents are sort of taking the shapes that we know, but they're not quite there yet. And I want you guys to notice this thing called the Western Interior Seaway, where North America was split in half. That's kind of a thing. And also South America is pretty isolated. That is also kind of a thing. So we're gonna talk about the Cretaceous. Dinosaurs diversify even more. We get all more really cool, crazy dinosaurs. Angiosperms, the flowering plants begin to take over, which I talked about already. We get the first magnolias, we get the first laurels, we get sycamores, we get oaks, we get palms. All this is due. And we also get the first snakes. The first snakes basically evolved to eat our ancestors. Because we were just a bunch of little rodents for the most part, and we burrowed in tunnels, and snakes are really adapted to eat rodents. The sauropods, which I talked about, the long necks, declined, but they got really interesting because the ones that were left behind kind of wound up on South America, most of them, and Africa too, the southern hemisphere. But they start doing some really interesting things. Some of them get tail clubs, some of them get armor, and some of them get really, really, really fucking big, really, really big. And we get mosasaurs, which are another group of seagoing reptiles that are actually related to monitor lizards. But nobody picked any mosasaurs, so you'll have to look those up on your own. So now there's another dinosaur group that's on
the Dan,
yeah.
Dan, you said mosasaurs. Isn't that the one Nicolas Cage tried to buy the skull?
Nicolas Cage did try to buy a mosasaur skull. Yes, he did, and he failed. I think Leonardo DiCaprio beat him out on. Isn't that what happened? I believe
something like that. Something like that.
That was after he tried to buy the Tyrannosaur skull and had to give it back to China or Mongolia or whatever.
It's hard to be Nick Cage.
It's tough. It's tough to be Nick Cage.
Mm-hmm. Which actually, you know what? That's going to come back, believe it or not. We're going to talk about that. So anyway, this is the marginocephalans. These are basically animals with headgear. You get your pachycephalosaurs down here, and over here you get your ceratopsians.
Which was mine from last year. Yes,
some of this is a review. Now, the ceratopsians do split into two types. You get the ones up here are called kentrosaurines, and this is where we're getting a little more detailed. The ones down here are called chasmosaurines. And so, I could just ask, or I'll just tell you. Basically, the kentrosaurines tend to have bigger nose horns and not as big two horns above their eyes. And the chasmosaurines tend to have these big, long horns with their eyes, but then smaller little nose horns. So based on that, because we already did it last year. Do you think Triceratops is a kentrosaurine or a chasmosaurine?
Chasmosaurian.
Chadmosaurian.
Yes, exactly. Very good. Anyway, Marjocephalon's the one with the head.
It's the Bromosaurian. Chaz.
Chasmosaurine, right, exactly.
Chad.
They also only live in the Northern Hemisphere. They only live in North America and Asia. Also, oh boy, this is going to be tough for you guys. But I'm actually going to split these just for the sake of trying it out. I'm actually going to mention what's in what age. So not only is this the Cretaceous, but I'm actually talk about the different ages, which is where you get really into the nitty gritty of what's in what. And there's a reason for that. I'll get into later.
Don't worry, Dan. We'll try our best to keep
Do
up.
your best. Do your best.
Dan,
Yeah.
I'm worried if you get into the nitty gritty that we might get detailed about this stuff.
Right, I know.
That's troubling.
That's true. All right. I think this was Lauren's pick. This is Psittacosaurus. It lived in the Aptian to the Albian, which is so early-ish Cretaceous still. It's an early ceratopsian from Asia. And we know a lot about this dinosaur, including its butthole. They found, so many people posted on my wall last year because they found a really well-preserved Psittacosaurus that was like confirmed what its butthole looked like. And surprise, surprise, its butthole was, it had a cloaca, which is not really surprising. A cloaca is what both alligators and crocodiles have and what birds have. It's just one opening where everything goes in and out. But it was like this cool confirmation that, oh yeah, dinosaurs had them too. They had cloacas, what do you know? So anyway, that is Psittacosaurus. We also know it had a funny prickly tail. We found the prickles on its tail that it had. And we know it was actually, we even know its color, because we could look at the melanosomes. So it had a rusty reddish brown color to it. And there's a whole eons about Psittacosaurus. So there you go. This is Matt's pick. This is Manipulator modificaputus, which lived in the Cenomanian. Is a predatory cockroach found in Myanmar amber. It is an early member of Mantodea, so it's a early mantis, basically on the line of mantids. And it's one of these amazing fossils, but actually, I'm going to talk about this quickly, but amber from Myanmar is kind of a bummer because it's just a whole ethics thing where like these fossils are being used to like fund the military operations there, and they're doing some really shady stuff. And there's this whole like thing of like, we're getting these amazing fossils, but we shouldn't be buying them, and it's this whole thing. And that's kind of an interesting, there's a lot of actually interesting ethical dilemmas with paleontology, because a lot of these fossils were taken from places, and now some of these places want them back, like Nicolas Cage's dinosaur skull he tried to buy. And it's this whole interesting thing to talk about that we won't go into too much, but it is something worth mentioning, because these are some absolutely amazing fossils that come out of Myanmar. And there's another picture of it, well, more like well-drawn picture of Manipulator.
How large?
Not huge, like big cockroach, but like big cockroach. Not like this is not like Meganeura or anything. This is another fossil from Myanmar that was a huge deal. What do you guys think that is? Feel free to chime in.
I think Jen is right. I think it's sperm.
Yeah, it's sperm.
It's not sperm.
Is it amber?
There's a couple of
ants. Velociraptor entombed in amber.
Amber? It's something in amber.
Is it Dino DNA?
Dino DNA.
Not Dino DNA, but it's close. So there are a couple of ants in here, but the big thing that you're seeing is a dinosaur tail covered in feathers. So this is really, it looks like, it's a freaking dinosaur tail. So this is a little drawing of what maybe it looked like. It's kind of cute. But that's why it's really tough, because it's like these Myanmar fossils are finding actual freaking pieces of dinosaurs, but it's this whole ethical problem. All right, we're going to talk about crocodile now. This is Caprosuchus. This is not a dinosaur, but a croc. Lived in the Cenomanian. It's a boar crocodile from northern Africa. It was about 20 feet long, so it wasn't that big, but decent sized. I wouldn't want to meet one. And even its nose was like armored like a battering ram, and it could like run around. So this is like a running around croc that would run around and bite shit, and probably bit dinosaurs and ate dinosaurs and did all kinds of horrible things. It was pretty rad. And this is Polycotylus. This is because somebody asked for a plesiosaur. We did 2 plesiosaurs last year, so I had to find another one. This is from the Turonian to the Campanian. It is a plesiosaur. You don't have to worry about that. It's not a pliosaur, it's a plesiosaur. That's a plesiosaur split into 2 groups, and the pliosaurs tend to be the ones with the short necks, but this one, even though it has a short neck, it's not actually a pliosaur. Don't worry about it. That's okay. It lived in that Western Interior Seaway that we talked about. And what do you notice? What do you think is happening in this picture, by the way? What is this Polycotylus?
Giving birth. Baby.
It's giving birth, yeah, underwater. 16 feet long. Yeah,
Dan,
Max, what's up?
I have a quick question. Is there anything that we are going to have to worry about?
Like, is it on the final? Is it on the final exam? Is that our...
Max, you should always be worried about everything at every second of the day.
Oh, okay.
All right, so anyway, and this fossil of Polycotylus they found one that was giving live birth when they found the fossil. It died giving live birth.
Where did they find that? Is it in Utah or something?
Yeah, so that's the Western Interior Seaway is just because of that. It was full. It was like shallow seas are just great for life anyway, and then it also preserves fossils really well along the shores. So
I wonder if the artist is troubled here with all the dark colors and it's being birthed, but it's not really like, joie de vivre. I'm worried. But this is a beautiful dinosaur.
It's not a dinosaur, Dylan.
Damn it. It's more.
Yeah.
Happy birthday, Dan.
Thank you.
Surprise everybody. Hi.
Oh, and here's your dinosaur.
Oh, perfect timing.
There you go. This is Dreadnoughtus.
I did not think I was going to make it tonight, so this is a treat.
There you go. So perfect. You hopped in time for Dreadnoughtus.
Was that last one mine?
What? Yes, that was yours.
I saw it. I just didn't have my camera on.
All right. So this is Dreadnoughtus. Dreadnoughtus is a giant sauropod. So remember I talked about how the sauropods in the southern hemisphere got big and interesting. This one was one of those really, really big ones. It lived from the Campanian to the Maastrichtian, which are the last 2 periods, last 2 ages. It's one of the largest semi-complete skeletons of any dinosaur ever, which sounds like a lot of modifiers, but that's what it is. And it is so the sauropods in the southern hemisphere, a lot of them became what are called titanosaurs, which really just means they were just mostly really, really freaking big. And it was 85 feet long, 49 tons, like 2 stories tall, maybe. So it's in the running. Here's a bunch of really big dinosaurs. Generally, they think Argentinosaurus is the biggest. But there's also this one up here, Puertosaurus. There's also one that's not even on here called Patagotitan. But all these titanosaurs were just absolutely gigantic in South America. Here's a little person, if you're curious. And here's all these sauropods. So they were really damn big. But Dreadnoughtus, they have more of the skeleton. So that's why they say it's more complete than these other ones. They only have a few bones. But yeah, big ass dinosaur.
Why were they so big?
That's again, they don't really know. It's because it's probably like elephants. Once you get that big, nothing's going to bother you. But it's real crazy that they got that. I mean, it was to eat the big tall trees, but at least by the time you got the Cretaceous, those big tall trees were not as common. They were still around, but there was nothing like it had been before. But for whatever reason, the sauropods in the Jurassic just continued to get bigger and bigger and bigger. Or the Cretaceous, excuse me, not the Jurassic. We're in the Cretaceous now. Now we have another croc. We have Deinosuchus. This is one of my favorites. This is a huge crocodile from the Campanian, 39 feet long. It was pretty much all over both sides of North America, cruising that interior seaway, going wherever, chomping on dinosaurs, just causing trouble everywhere. It's maybe not the biggest croc ever, but it's definitely in the conversation. It was a really freaking big crocodile. And so here's a bunch of really big crocs. This is kind of just a bunch of them. Deinosuchus they put at the top, but some people argue about which one's which. What's interesting though is that this one and Sarcosuchus are both from the Mesozoic. These other three actually don't show up until the Cenozoic. So it's not like the Cenozoic just showed up and then the crocs all got small and that was it. Like there were big crocs, there've been big crocs around forever. This is a saltwater crocodile down here, which is the biggest crocodile we have today. So they're still like twice as big basically as a saltwater crocodile. So I love Deinosuchus. Deinosuchus is freaking awesome. We have a turtle. We have Archelon, which lived in the Campanian. It's the largest turtle ever at 12 feet long. It lived in the Western Interior Seaway, cruising that interior seaway. It's not a direct ancestor of modern sea turtles, but it is kind of a big sea turtle. And there's a whole eons about Archelon. You can check it out. But Archelon's great.
Do you think I could have ridden it like a sea pony?
I mean, if you can grab a sea turtle in Hawaii, I bet you could grab an Archelon. Like,
and Dan, your image here is a diver. Your image includes a diver taking a picture of it, and it's 80 million years ago. Were humans there?
Nope.
So your picture is not factual.
You're right.
That's not a human. That's a dinosaur with a camera.
It's called.
Okay, thank you, Max. Thank you. That calms all my nerves.
It's called art, Brian. Anyway, now we're gonna go to Cosmoceratops. I think this is Kelly's pick. Is Kelly here? This is a ceratopsian from the Campanian. So everybody loves Triceratops, but there's so many other ceratopsians. So we're gonna have a few other fun ones. Do you think this was a kentrosaurine or a chasmosaurine? Based on what go ahead.
The second one.
Chaz, baby, Chaz.
That's a Chaz. This is a Chaz. Yeah.
It's always Chaz.
It's, yes, often called the horniest dinosaur ever because it had all these little horns along its top of its head.
Definitely a Chaz.
It's a Chaz, baby. It's Chaz.
Yes. Yeah. It's an example of Chasmosaurine. Now we have Kentrosaurus.
That one fucks.
Now, do you think this is a Kentrosaurine or a Chasmosaurine? This should be pretty easy.
Kentrosaurine. Come on, everybody knows.
Yeah, this is a Kentrosaurine. So they got the one big horn. It also lived in the Campanian. All these three of these ones in this row all lived together. And they think it had these big herds because they have the largest bone bed ever found, had thousands of these in one bone bed together.
This guy Bone.
I have a question.
Yeah.
As a dinosaur that clearly has a gigantic horn, why is this not the horniest dinosaur?
This one has more horns.
Yeah, but that one has a bigger horn.
Well,
what's the volume of the horn?
There's, Max?
Quantity over quality.
Yeah, I don't know, quantity over quality. I guess that's the thing. That's the
this
point.
one seems
better. It's quantity over quality.
This one seems
because Dan said that the other one was horniest because it had more horns.
Max, I did say this was off. It said the horniest dinosaur ever. I guess I should say this is often called the horniest dinosaur ever.
It could stab more things at one time.
Can you please cite Can you please cite the horniest dinosaur ever? Can you please offer us a quotation citation?
No, we gotta go, guys. We have more dinosaurs to do. We gotta go.
The largest bone bed ever.
We've done this for an hour, so we gotta keep going.
Don Juan de Santrosaurus.
There's not a lot to do. And these poor guys got cancer. This is Jen's pick, and we actually found one that had suffered osteosarcoma, and the poor dinosaur died from osteosarcoma. It's actually very common with dinosaur fossils. They actually find it all the time. Which I think is actually really interesting. It just shows that these animals were like animals today. They had diseases and they had to survive things. And here's actually the bone they found from a Kentrosaurus with the tumorous mass in its bone. Poor guy.
Oh my
Poor
God.
girl. Oh. Here's Styracosaurus. What do you guys think? Chasmosaurus or Chasmosaurine or Kentrosaurine?
Petra, right?
Chaz, baby, Chaz.
Kentrosaurian.
This is one of my favorite dinosaurs, by the way. It's up there. It's another Kentrosaurian. But this is kind of complicated, but there's an interesting video about it. So there's a thing, and they never had talked about, they're always arguing over genus versus species and stuff. They used to split a bunch of these things into like 3 different species. There was Spiclipius, there was Rubiosaurus, and there was Styracosaurus. And then they found a skull that looked like half of a Rubiosaurus and half of a Styracosaurus. And because it had been like deformed as a kid, and they kind of were like, wait a minute, these are just dinosaurs that just their skulls kind of grew in differently, and that gave them different headgear, and actually is all, so like now they kind of think they're all Styracosaurus, like they kind of had to change things up. That was a pretty recent discovery. But I love Styracosaurus. I just think it's got a lot of attitude. This one killed a raptor. They're just really cool looking dinosaurs.
I have an actual real question now. I know this might be an artist's interpretation, but
yeah. Good. Yeah, go ahead.
No, this actually it looks like there's a face on top of his head, or at least eyes. Did they find anything that would suggest that it was a defense mechanism or something to frighten them away, or is it an artist interpretation?
That is an artist interpretation. I think it's a neat idea because it's like kind of like butterflies have that, right? They have the eye spots. Maybe it was, a way to attract mates too or something, but it's just a neat idea that's not based on anything. But they thought, wouldn't it be cool if it had these little eye spots on its frill?
Yeah.
The other thing that's really interesting, that specifically the guy, Mark Whitten, who drew this painting or drew this drawing, whatever it is, this piece of work, he specifically was like, I want to have it killing this raptor, but also maybe it's eating this raptor because we don't know. And we're like, what? We do know it. It was like a plant eater. And he's like, well, deer have to grow these big long antlers, and male deer will often, and even cows will often eat bones and stuff to get that extra calcium to grow their antlers. And they're like, maybe there's things that dinosaurs would do that too. So that's kind of was his fun way of like showing a rare but possible behavior.
Yeah, this is fascinating, but time out. We have deer and cows that eat bones. Is that
cows will sometimes eat nests of baby birds, and deer will often scavenge bones to help, especially during the rutting season, because deer have to grow those antlers every year, right?
Yeah.
So it's not often, but it happens. So he was just like, maybe, he's like, dinosaurs, just because it says the planet doesn't mean it didn't do things like that from time to time.
Well, you're 2 groups. One has the nose one like points up. It's like it's attacking things. And then the other one has them like from the forehead down, like it would defend itself.
Yeah, maybe. I don't know. Anyway, that's the last of the search. Oh, no. And then just like you guys asked, actually, the horns were maybe used for defense or maybe just display. We don't know. Now we have a Letopelta, which is an ankylosaur, one of these armored guys. Also the Campanian. It is a mid-sized ankylosaur from Carlsbad, California. But wait, California was underwater. How did they find a dinosaur there? Well, this was likely an ankylosaur. They call them bloat and float specimens, where it had died on the land and then floated out to sea and then sank. And then all the gases in its belly built up and it floated back to the surface again and then went somewhere and got fossilized. So they know that because they found bivalve fossils on its bones, and there's evidence that the bones were scavenged by sharks. So it's a dinosaur carcass that got washed out to sea. And there's a whole eons about bloat and floats. So take a shot. Now we have Oviraptor, also lived in the Campanian. Name means egg thief, but it lived with Protoceratops and Velociraptor, lived at the same place as those guys. But even though its name means egg thief, that's because they found it with these eggs. So they thought it was eating all these eggs that they thought belonged to Protoceratops when they first found it. Turns out it was actually protecting the eggs, and it was its eggs. Once they found some more of these eggs, they opened them up, they realized it was actually taking care of the eggs, and it was the mommy of the eggs. Or maybe not the mommy. We'll get there in just a second.
That's me.
Oh, this is yours? That's right. I couldn't remember who picked this one. Sorry. So they think it was omnivorous or maybe even frugivorous because it had this beak like a parrot. This is the Big Mama fossil, a famous fossil where they found it dying, protecting its eggs. But they've actually looked, and with a lot of dinosaurs, especially theropods, they can find what's called medullary bone or medullary bone. Medullary bone is something that birds do, where when a mother bird is laying eggs, she gets more bone in her bones get heavier around her hips. And they've been able to find that in dinosaurs too. So actually, by looking at that medullary bone, it looks like actually the males may have done all the nesting and actually been the ones who protected the eggs. So maybe it wasn't the mom after all, maybe it was the father.
Stay-at-home dad.
Yeah. There's an Eons about Oviraptor if you want to check it out. And there's a couple of Oviraptors, and I love this drawing, but really, they kind of males are probably, this is probably the male, this is probably female, they're probably switching places based on what they recently found. And I have two more crocodiles for you. These are some weird crocs. This one is Armadillosuchus, which lived in the Maastrichtian. It was an armored digging crocodile from Brazil. So it ran around, dug burrows, and it had armor all over it. And this is Simosuchus from the Maastrichtian, and it was a little pug-faced crocodile from Madagascar. So they're just a couple more fun crocs. I kind of wanted to show that crocs were doing cool stuff throughout all this time. So now we have my pick. I want you guys to chime in. What do you think this is? David can't play because David already knows.
This is amazing.
That's from
what? That?
No,
What is that?
That's my new outfit.
Yeah, this is from that Cronenberg movie, Dead Ringers.
What do you think it is? Anyone else? Any other guesses? What do you think that belongs to? What kind of creature would have arms like that? It is a dinosaur, so it's a dinosaur, but what kind of dinosaur do you think that would be?
What is it?
What's T-Rex?
Would it be a T-Rex?
Like T-Rex hands.
Yeah, it's
T-Rex has tiny little hands, right? Remember?
Yeah, this is a ripping.
Well, tiny to other things, but huge to us.
Not that big.
This is the Spinosaur from Jurassic Park 2.
Is it an Archosaur, Dan?
It is because it is a dinosaur. I'm giving
that's a Triceratops.
Why is it a man with a hat? It's a man with a hat.
What is an Archosaur again? I missed it.
An Archosaur is the group that contains crocodiles, pterosaurs, and dinosaurs.
Okay.
Yeah.
Is it an Allosaurus?
Not an Allosaurus, no. So I'll just tell you now. I'm gonna get into it.
Can we have a hint?
We're dying, Dan. Tell us.
Why?
Well, for the longest time, paleontologists didn't know either. They found several of these giant arms, and they never found the rest of the dinosaur. And they were like, "What the fuck is this thing? We don't know what it is. It's crazy looking. We have no idea." And they finally, pretty recently, not like super recently, but like recently enough, found the rest of it. And it looked like this. And it's Dinocyrus. It's a really, really crazy ass dinosaur. So remember that bit in Jurassic Park where they're running in the field and there's all the little ornithomimosaurs going blah, 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 running around like these guys over here? It's in the same line as those things, but rather than be small and fast and run around, it just is this big, slow, hulking, slothy thing called Dinocyrus, which means terrible arm. It lived in the Maastrichtian, and it was a giant ornithomimosaur from Asia. They found fish scales in its belly. It also had gastroliths. They think it ate plants and fish. So this big, slow-moving giant duck that was honestly almost
Ornithomimosaur?
Ornithomimosaur. Sorry about that.
That's a lot.
Ornithomimosaur are the ones in Jurassic Park running in the field.
Oh yeah.
Yeah.
Okay.
Ostrich. They look like, most of them are small and look like ostrich dinosaurs.
Yeah, just how many prefixes is that strung together?
Does that just mean bird mimic or something?
Correct. So ornithomimosaur, there is a dinosaur actually just called Ornithomimus, which just means bird mimic. But there's that group of dinosaurs, they all look like those ones you saw in Jurassic Park running in the field for the most part, except for this guy who is just this weird, big, slow-moving thing. So
that's like a beetle on wheels. That's just like a T-Rex snack.
Yeah, I mean, this thing was almost as big as a T-Rex. This just this big, slow T-Rex thing. There's a whole eons about it, by the way. This is one of my favorite dinosaurs. I love this dinosaur. That's why I put it in. Now we have Albertosaurus. Which lived... What? Somebody was going to say something. No? Never mind. It's T-Rex's smaller Canadian cousin.
So they're nicer and quieter?
I don't think they were probably that nice. But it was a pack hunter, they think, because they found families of them together. And here's a question that I'm going to throw to the group. Do you think Tyrannosaurus had feathers? Yes or no? Who says yes?
Yes. Yeah.
Who says no? Nobody.
No.
Who said no?
Jay says no.
Jay says no. So
Alex says no.
here's the really interesting thing with tyrannosaurs as a group, is that we know early ones along the line have definitely were covered in feathers. And they even found one from China that's pretty big, like good-sized dinosaur. Not as big as T-Rex, but a big dinosaur called Eutyrannus from China, the Middle Cretaceous, and they know that one was covered in feathers. But the climate there was also pretty cold at the time. And then with T-Rex, we have found skin impressions that look scaly and have no feathers at all. So I personally don't think T-Rex had feathers. I think that T-Rex was probably a lot like an elephant today, in that technically has a little bit of hair, but mostly looks pretty hairless. And that's what I think T-Rex looked like. But that's all being debated. I don't think T-Rex was actually covered in fluff. I don't think that that's actually the case. But Albertosaurus was maybe, because Albertosaurus was earlier, a different time. Maybe it had feathers. We don't know. We're still learning. It's really interesting.
So Dan, actually, serious question. So say velociraptors were proven that they do have feathers, but T-Rex is still kind of debated?
Technically, they haven't proven Velociraptor had feathers, but it almost certainly did. There's no question. I mean, it's on the Dromaeosaur line, and Dromaeosaurs all have feathers. So it's just all. When were you here last year, Dylan? You were, right?
Absolutely, yeah.
So there was, when we get to the graph, I'm going to go to the graph again. I'll show you where the split happens, and you'll kind of see how it all works. But yeah. Now here's another weird question: did Tyrannosaurs have lips? And this is up for debate still.
I never thought before.
Well, so T-Rex is always shown with its teeth hanging down over its mouth when it closes its mouth, but that's almost no animals do that anymore today, except for crocodiles. But a lot of lizards kind of keep, it's not good to have your teeth hanging out. It's not good for your teeth. It's good to have them being covered and stuff. It's more healthy for your teeth. So a lot of people are wondering maybe if T-Rex had lips. There's no way to know. We don't know, but it's something you're starting to see some people try. So here's kind of a new T-Rex without feathers, but it's got these lips. It looks kind of like a big monitor lizard.
Everything else you have shown is like a cute little drawing, and that's fucking terrifying.
I mean, that's a T-Rex, though. It's a new looking T-Rex.
It's a new looking T-Rex?
It's just, this is a T-Rex with lips and no feathers.
Is there a lipstick version of this?
There is not. You can draw that one, Allison. I bet it would look great. So, guys, I'm making another drink. I'm going to take a break. I'm going to leave you with these T-Rexes, and I'll be right back.
You could have left us with the cute one.
No good sentence starts with, I'm going to leave you guys with these T-Rexes.
Okay, so how's everybody doing with this whole T-Rex situation right now?
Well,
you know, left us with the chunky crocodiles. We would have been fine.
How many Jelly Bellies gummies do we think Dan's eaten so far?
Plus, are they normal gummies or are they like?
I'm not doing weed gummies. No way, guys. I'm not.
Okay.
That's dangerous.
I was really hoping popping weed gummies like fucking pills.
Like 45 weed gummies.
This definitely sounds like
I thought you were.
Travel back in time.
No. These are just for ordinary fruit snacks for kids.
Ordinary fruit snacks for kids, he says, as he shows us terrifying animals.
These are, so we're kind of still about Albertosaurus. I met Albertosaurus this past year. I went to Utah, and there's a whole museum with dinosaurs, and these are some Albertosaurus that I met. I took their picture.
Albertosaurus.
What I like about these Albertosaurus, though, is that I like that these guys are just hanging out. Like, I think this one's worried about the other one. And it's like nice to see Tyrannosaurus specifically just being nice. They weren't always being horrible and roaring and eating things. In fact, they probably didn't even roar. I hate to break it to you guys. They probably didn't roar the way we think that they roared.
They're incredible dancers.
So I like that these ones are just being nice. They probably don't chirp. They think they probably make really deep booming sounds like an alligator that came from the back of the throat. And they probably yeah. Go listen. That's actually not far off.
Like zombies.
Kind of like hooting, booming noises. Listen to like what an alligator sounds like, and then pitch that way low. That's what a T-Rex maybe sounded like, or an Albertosaurus. And there they are again. This is from my adventure in Utah last year.
I've always thought about if we, were able to go back in time and look at all these dinosaurs. When you'd hear them, you go, "What is that?" And then you'd be dead because they happen to be right next to you and chomp you.
So this is just, I could go into this a lot, but it's not much. But the green one here is Albertosaurus. Here is T-Rex at the top. This is Tarbosaurus batar. So this is actually the one Nicolas Cage tried to buy. And there's Gorgosaurus and Daspletosaurus. So these are all the kind of late Tyrannosaurids. And they are actually, remember how I talked, they constantly fight over which of these is a species and which of these is a genus. Some people say Tarbosaurus batar should be Tyrannosaurus batar. Some people think that Gorgosaurus and Albertosaurus are the same thing, and Gorgosaurus should just be a subspecies of Albertosaurus. Doesn't matter, but here they are. Don't worry about it. I might just, oh no, this is kind of interesting. So I'm getting a little loopy. These drinks are kicking in. This is the campaigning. So last year I said before the asteroid hit, we all know it's coming, spoiler alert. I talked about how it looked like dinosaurs might have been in trouble anyway before the asteroid came. And there was a recent paper that said, no, that's wrong. Dinosaurs were fine. All that happened was the Western Interior Seaway was closing up. And when that happens, there's less fossils. The fossils aren't as easy to find because, edges of seaways are really, really good at preserving fossils, and maybe that's all that's going on. And the dinosaurs are just doing fine. It's just the fossil record. That was basically it. So that's basically what this graph is saying, is they're saying that these grayed out ones are just because their fossils are harder to find. I don't know if that's true. I also think that if an interior seaway closed up, that might cause some environmental change that also might be difficult. So who knows? I think it could go either way, but it's just kind of interesting. And that is the Campanian versus the Maastrichtian. So that is the kind of the change. That's why I wanted to go down to the ages. But don't worry about it. Moving on. I said don't worry about it again. You take a shot every time I say that. Now we go to the Cretaceous Paleogene extinction. There's an asteroid hit the Yucatan Peninsula. It didn't just wipe out the dinosaurs. It wiped out the ammonites and all tetrapods, which are the things that crawl on the land, larger than 55 pounds, except for some turtles and crocodiles. So it was a bad one. It means I should be eating some fruit snacks. But even though birds and mammals and crocs made it too, a lot of them really did die out. It wasn't just like, oh, they were fine. Like, no, everybody had a bad time. 75% of all species go extinct. But there's a really good Radiolab episode about it. You should listen to it. It's not on Eons, it's the Radiolab. That will be in the post-talk note. So last year I had you guys make this. I'm not gonna have you guys do it again, but here's kind of the graph that has all the dinosaurs from last year we did, and not just dinosaurs, but other creatures. So Dylan, if you're curious, by the way, this is a split off of theropods called the Paravians, which are very bird-like things. And that leads to some birds, but also the raptors are very close on that line.
Gotcha.
I've got some raptors there. And if you remember what we had last year, if I do a click, here's all the new ones we just added. Look at all those critters. They're all there. We could look at that for a bit, but we should move on because we got to do the last one, which is after the dinosaurs comes the Cenozoic, which means new life. There's an Eons about the Cenozoic. Check it out.
Drink.
So if you want, you don't have to, but you could draw this out if you wanted. This is our little graph of all the different time periods in the Cenozoic.
This is going to be on the test, doesn't it?
Probably. So, first up, is the Paleocene, which is 66 million years ago, 56 million years ago. And the first mammal groups really begin to take hold, but they're kind of smaller. And there are dense, low diversity forests everywhere because a lot of things have died out. So low diversity, but big, dense forests. It was really, really, really warm, warmer than even the Mesozoic was. And ray fin fishes, which are kind of the fish you see everywhere today, start taking over the sea.
Wait, like how warm?
We're going to get to there. Don't worry. Just wait. I don't remember off the top of my head, so you'll find out. So here you go, Sonia. Here is Titanoboa.
Yeah, I'm so excited.
This is a boa that lived in Colombia from 60 to 58 million years ago.
Fucking way. Oh my
And
God.
by the way, so what happens when things get really, really warm, just like if you go to Florida or if you go to Arizona or whatever, is it's really, really great for reptiles. So a lot of reptiles actually did, even though the dinosaurs died out, reptiles actually did really well in this time, which is part of why we got Titanoboa, which is the biggest snake ever at 40 feet long.
Oh my God, no.
And this warm climate allowed it get so big. It probably ate other stuff, but they do think it ate fish too. And there's a whole eons just about Titanoboa. So you can check out Titanoboa, but Titanoboa rules. It's super cool. Also, here's one that's a fun one. It's another turtle. This is Carbonemes, which lived at the same time. So if you're like, oh, these snakes, I don't like these snakes, I'm going somewhere else. Well, this is a giant carnivorous side-necked turtle from Colombia.
I would ride that turtle.
Its shell's over 6.5 feet long. So it wasn't huge, but it's pretty big. And it ate meat. It ate little mammals and lizards and things. It was a meat-eating turtle crawling around. So that's Carbonemes. And so that and Titanoboa were both hanging out at the same places at the same time. So this is important. We're going to talk about the Paleocene, Eocene, thermal maximum. So it was really warm the whole time, but at the very end of this time, there was a 5 to 8 degree temperature rise in less than 20,000 years, which is really, really fast. And that lasted for 200,000 years. It was 73 degrees at the poles, and in the polar oceans, it was 68 degrees. So it was really, really warm. So at the equator, you couldn't even live in like a lot of the oceans couldn't even live in. It was like being in a hot tub. And there was mass die-offs of corals, the ocean acidification went amok. It was real bad news. There were palm trees in Wyoming. And this was caused by the release. They don't actually know exactly what caused it. I think a bunch of carbon dioxide methane was released from the ocean for whatever reason. And that led to a runaway greenhouse effect caused by wildflowers, volcanoes, melting of methane hydrate. Actually, sorry, I take that back. It was caused by all this carbon dioxide, but part of that was because of those big giant forests. It was, again, the forests were shooting out all this CO2 that was just not getting consumed. So that was also a piece of it. However, as scary and hot as it got, those carbon emissions are only 1/5 of what is being emitted today. So we might want to watch out what we're doing, basically. Because last time this happened, it was pretty nuts. However, though the emissions from this time went on for thousands of years, where ours have not gone on for thousands of years yet, but we're doing it much, much, much faster. So we don't know why this ended. There's this thing, maybe the plant saved us. There's this thing called the Azolla event, where all of these mats of Azolla, which is this little plant, were all over the Arctic. And they think that maybe when they kind of died out and sank to the bottom of the ocean, they like trapped a bunch of that carbon and helped bring things back down again. But they don't really know. Anyway, it's a really crazy, crazy thing that nobody talks about, but it's pretty interesting. And there's a whole eons about it if you want to check it out. So.
Shots.
Now we move into the Eocene. So things finally started to slowly cool off. They were still pretty warm, but they did cool off a bit. And a lot of the modern animals and plants start to develop. Ungulates dominate. Even predatory ungulates called mesonychids are running around. Ungulates are animals with hooves. So animals with hooves start really taking hold, but there's even ones that eat meat, chase other animals with hooves and eat them. Here's another crocodile. This is Bovarisuchus. This is a terrestrial galloping hooved crocodile from Asia. 10 feet long. There's an eons about it. I just wanted to include a lot of fun rocks. This is Basilosaurus. Brian, this is yours. This is an early whale, possibly the largest animal in the Paleogene. So that's the first chunk of time in the Cenozoic. One of the first fully aquatic whales, probably. And there's an eons just about Basilosaurus for you. So here's a little thing about whale evolution. So kind of just shows you how they went back into the oceans, basically. But Basilosaurus is here. It was pretty damn big. It was a big one. They kind of started out as these hoofed animals and then moved into the oceans. They're probably close, I think they're most closely related to hippos, but I'm not sure on that. Oh, is Ryan here? Because Ryan, not my brother Ryan, the other Ryan. I don't know. Brian gave me a really hard one. Ryan was like, I want to learn about these new giant clams they found. And they were like confiscated. And they were actually really hard for me to figure out because I don't think they were actually that old, the giant clams they found, but I did find out about the history of giant clams. So we're gonna go into that. So today, Tridacna gigas is the largest clam alive. And they found some fossils of Tridacna gigas. And they have a mutual relationship with algae. A lot of that happens, a lot of corals and jellyfish and stuff. And they think that happened during this time. That's when this mutual relationship that helps out coral reefs and giant clams happened right around this Eocene-Oligocene transition. The largest clam ever was in the Cretaceous. It was called Platyceratops. It was really big. It was bigger than that. Okay, the Eocene-Oligocene transition. There was an extinction event, but not a big enough one to consume fruit snacks over. The climate got cooler. It was possibly caused by an impact crater in the Chesapeake Bay, or maybe there's only one in Siberia they think might have caused it. So a smaller asteroid. I think what they're kind of learning is that the asteroids hit the Earth a lot more than we like to think they do. But then we enter the Oligocene. It's kind of a period of transition. A lot of the older animals start to die away and new animals take their place. We start getting grasslands, tropical forests retreat back to the equator where it's, instead of being all the way up to the poles. And I already kind of said that. This possibly ended with another impact crater in Nunavut. So a lot of impact craters. This is another one that Jess wanted. This is Goliathea. This one's Goliathea up here. It was closely related to shoebill storks, which are in the same family as pelicans and herons. So it ate lungfish and catfish, which were also found in the same habitat. Here it's attacking a terror bird, which nobody really picked, but these were these giant flightless birds that walked along the Earth. And we're going to go into Miocene. Oh my gosh, I need a break. Okay, no, we can do it. Okay. This is the beginning of the Neogene period. So we are moving from the Paleogene into the Neogene. The world continues to get cooler. There's more grasslands and the first kelp forests. And the plants and animals tend to be recognizably modern, except for in Australia and South America, which were still isolated. They were really, really weird down there. We're gonna get some weird ones coming up, I promise. And apes evolve and start to diversify. So that's interesting. Here's glyptodonts, which is a whole family of creatures.
What is that?
This is a glyptodont. Haven't you heard of glyptodonts? Glyptodonts are great.
I think it's a glyptodont.
Glyptodonts. It's a glyptodont. So they are a type of xenorthrin nested within armadillos that lived 20 million years ago to 10,000 years ago. So it's the whole family of them. They actually lived for quite a long time.
Does that have an arm coming out of its back?
No, it's his tail.
Everything about this sucks.
Glyptodonts are rule. What are you talking about?
Definitely my friend.
I want a glyptodonut.
It's a type of xenorthrin, which are the same family as armadillos, sloths, and anteaters, which first appeared in South America. So this is very closely related to an armadillo. It's basically a big armadillo, and some of them, like this one, had tail clubs.
Wow.
Yeah.
Could they move it like a tail, or is just kind of just?
I think they could whack you pretty good.
Okay.
I wouldn't. Yeah. Here's another crocodile. This is Morasuchus, also a South American filter-feeding caiman. So it was a caiman that was like a pelican or a duck or something that filtered its food through the like that. And actually, it was not the first filter-feeding croc. There were other filter-feeding crocs all the way back in the Cretaceous. So it's apparently crocs every so often were like, I'm going to filter some fish. Or filter, not fish, small creatures, not be a big old scary croc. Here's Stupendimes geographicus, which is a giant freshwater side-neck turtle from South America. So I kind of include a lot of reptiles. I think people kind of think reptiles stopped doing interesting things after the Mesozoic because the dinosaurs die out. And I'm like, no, reptiles were still doing cool stuff. So this one's nearly as big as Archelon, but it was like a river turtle. And it lived alongside giant caimans and rodents. So South America, this is all South America was crazy. It was a crazy time. This is an island continent.
What does a side neck mean? What does that mean?
Side neck turtles is just a group of turtles that
Can they turn their neck to the side?
Yes, they can. Some turtles can't do that, and side neck turtles can.
Cool.
Most turtles, when you think of a turtle, you're usually thinking of a side neck turtle, usually. But a tortoise is not. There's something else. I'm not sure on that though. So please, I could be wrong. Here's two more turtles and then we're done with turtles. Testudines is the group that includes all turtles. This is Meolania, which is a large armored turtle from Australia. The largest species was 6.5 foot long shell. And it had like a big old clubby tail and horns, it had armor all over its body. Like your turtle needs more armor, but this one had more armor. This is Megalochelius altus, which is the largest tortoise at 8.5 feet long. And this one's for Colin. This is Machairodus lahishupup. I can't even say it. This is a very recently found large Machairodon, which is a type of saber-toothed cat. They first appeared 60 million years ago, but this one actually was from 9 to 5.5 million years ago. So Machairodon's the whole group that includes saber-toothed cats and the famous Smilodon. That's the one people usually know, but there were lots of other ones too. This one was actually probably a little bigger than Smilodon. They think that Machairodonts were ambush predators because those teeth, as cool as they look, are very delicate. So they think they kind of hid, rushed out and grabbed their prey, and then basically stabbed them with their saber teeth and delivered the killing blow. They know that they lived in families that took care of their kids. And there's a whole eons about saber-toothed cats in general, not this specific one. And I'm about to ruin saber-toothed cats with you, just like I ruined T-Rex, because a lot of people think now that saber-toothed cats had lips. Oh, there's also a podcast about these guys. I'll send that too before I get there. But they think saber-toothed cats had lips also, kind of like jowls. So here's what they kind of really think a saber-toothed cat maybe looked like a little more. They're kind of like big old jowly St. Bernard kitties.
What? I love even more precious and perfect. Perfect child.
Adorable.
They always kind of show them with their big teeth hanging out, but now they're like, actually, maybe they were like this. Maybe they kind of like kept their teeth inside with big old jowls.
I just want to throw a stick.
Mm-hmm.
Yeah, I want to own this. This is the only cat I want to own.
Yeah, jowly boy.
Jowly cat.
Delical jowly boy.
Thylacosimilus. Do you guys think this is also a Machairodont, also a saber-toothed cat? What do you guys think?
It's two arms hanging out of his mouth. Dude.
That's a little baby in a pocket.
That's a marsupial.
Oh, yeah, that's a marsupial. What the hell?
This is a marsupial.
That thing goes to my baby.
This is, it means pouch knife because it's got a pouch and it's got big old knives.
I'll get you.
This is a saber-toothed marsupial down in South America. I told you, South America was nuts. So saber tooth developed also down in South America, just convergent evolution, different creature got saber teeth, but it was a marsupial. Yeah, it was giant saber tooth marsupial from Australia. Actually, that's wrong. It was giant. It wasn't that big. It was not as big as the saber tooth cats. It was smaller. That's kind of a mistake. I just like putting giant on things. I guess I got carried away. It had a delicate but very wide bite. It could open its mouth crazy, crazy wide, wider than even a saber-toothed cat could. And they could also do this. So probably to then get those teeth in. Here is for Alex and Celeste. They asked me to do sloths, but we already did the big giant sloth last year. So we're going to do some other sloths. So this is Thalassocnus, which is a semi-aquatic ground sloth. It was like a sloth manatee that ate seagrass. And it had heavier bones to help it sink to the bottom, so it ate all the seagrass, and the nostrils moved up the top of its nose so it could like get air easier. And they know these killer dolphins ate it because they found bones that have like the like teeth marks that match these killer dolphins. And there's an eons about sloths, but also specifically goes into Thalassocnus a bit. So that's Thalassocnus.
Wait, no, Dan, wait, just to describe the sloths, are they like underwater Unterwasser sloths? Is that what's going on in that image?
Underwater sloths.
Yeah, Unterwasser.
Yeah.
Underwater sloths.
Thank you for making that German. Yes, Unterwasser.
Underwater sloths. They were basically
sloths are even faster.
like manatee sloths that like they still had to breathe air. But they would kind of cruise around underwater and eat seagrass.
The fastest sloths you ever could see.
They're like the U-boat sloth. They go under the boat.
Yeah.
All right.
Good.
Now we go to the Pliocene. So something interesting about this that we're gonna get to, but what are these?
Fuck if I know. Elephants?
Elephants,
right. But what's this over here?
An armadillo.
Not an armadillo. We talked about them.
That one from
Glyptodon, yeah. But the glyptodons were in South America, and elephants, at least the mammoths and stuff, were all in North America. So that's weird.
Pangea.
Well, Pangea is way in the past. What's that about? We're going to find out.
They flew there.
Yeah, we'll get there. Don't worry. So this is the Pliocene. It gets drier and cooler. There's more grasslands, more grazers. And North and South America finally get connected right around here. And the first Australopithecines show up in Africa.
Ooh.
So this is the Great American Biotic Interchange. So right here,
Summer of Love.
Things get connected, right? Exactly. So here's an armadillo. Here's a capybara. Here's a couple big sloths. Here's a glyptodon. Here's a terror bird. And over here is a mammoth and some other stuff, Smilodon. And basically this stuff got connected, and all the animals suddenly they were able to run around and meet each other and everything. It was like after COVID. And
oh no,
it happened around 2.7 million years ago, and it was not a sex thing. It's the Great American Biotic Interchange.
What's the toucan thing?
The toucan thing, that is a terror bird. We didn't go into them, but they were these big flightless birds that they used to think ate meat. Now they actually think maybe they were like coconut huskers, which is way less cool, but they were still pretty cool. They were big old bird, like flightless birds that ran around.
Coconut huskers?
That's the new thing. They think they ate coconuts and big nuts with those big beaks.
Dan, what is the orb lizard?
The what? This?
The orb lizard? Yeah.
The orb lizard, we did it twice. We talked about it twice.
That's the same. He's my favorite.
He looks more round.
It's a glyptodon.
I want him, and I want to just roll him.
They're great.
What's the dodo bird over there in that picture?
I just told you. that's the
I've been drinking too many eons, man.
And I sure was the dumb one here for like 1 second.
That's the terror bird. There's a whole group of them, but they're terror birds. They're called the forest racids, or forest racids, and they're these giant flightless birds with big, horrifying beaks. They were way bigger than. They weren't as big as an elephant bird, but they were bigger than ostriches by far. They either ate small animals, or now they think that maybe we're just eating coconuts and nuts and things. But
wait, how tall is that giant sloth?
the sloth, this is probably not the biggest. Well, I don't know. The largest ground sloth ever was as big as an elephant.
Wait, is that to scale?
No, well, no, because there's the Panama Canal. So,
No, that's to scale. That's correct.
That's to scale. Oh my god.
no, it's not to scale. But it is, I mean, I guess they're more or less in scale with each other.
There was this one
warm,
sloth
so-
the size of Wyoming.
One sloth that was as big as
His name was Jeff. Jeff.
He was a prick.
Jeff was an
Such a
asshole.
prick. I don't remember. I never told you, but I was one of those time traveling, picture takers. It was a master's program. It was a whole thing. Jeff was.
All right.
I'm sorry,
Yeah.
Sonia established.
We're almost
for me
there, guys. We're in the home
that
stretch.
it's a timetographer.
All right.
You have to get it right.
The great North American interchange, or no, American interchange, whatever, biotic interchange happens, and we move into the Pleistocene. You guys should know what the Pleistocene is, maybe. 2.6 to 11,700 years ago. That's the Ice Age.
Right, movie.
So the sea levels, when all the ice gets trapped, all the sea levels go way down. So that's part of why this interchange happened. And Homo sapiens evolves. Oh no, and it gets to every continent, causes all kinds of horrible trouble. So here's Max's. This is Elasmotherium. This is the one that showed up in The Mandalorian, except it was in the mud for some reason. It lived from this long. I'm not going to go with the time periods. You can read it later. It's a big run one-horned rhino. Max is mad that I didn't read his time period. I can see it on his face. It's 2.6 million years ago to 39,000 years ago.
Yeah, check out Misha's glasses.
I forgot them. Sorry.
Oh, Misha, I have them too.
Yeah, put them on.
There you
I
go.
can't. They're a little dirty, and I can't see the screen as well.
Looking pretty cool. Looking pretty cool, guys.
I'll keep them on for the both of us.
Okay, great.
Aren't all rhinos only single horned?
No.
Yeah.
The black rhino's got two horns, right? And this one it was a really big one.
And it has hair.
So one-horned rhino. The largest species, the Siberian unicorn, was the size of a mammoth. So it was pretty damn big.
Guys, it's a unicorn.
Yeah, it's the unicorn.
What kind of brush do you think you would need to brush his hair?
A curry brush?
I mean, what's the equivalent of a boar at that time? So you can have a boar bristle brush?
Anyway, let's move on. We're almost there. Allison, this is yours, right? I think this is yours. Yeah.
Yep, that's mine.
Megaloceros. This is the Irish elk, but it was found throughout Eurasia. The largest species of this was bigger than a moose. So it was a really big deer with these huge horns. Or excuse me, not horns, antlers. They don't have horns. Get it right, Dan. And what's cool is that we actually know details about this deer because it's found in a ton of cave paintings. So that's why we know it kind of had this hump. It's why we know it had these stripes along its front and then kind of the pale patches along its face. That's all they know that from cave paintings. So unless all the different cave paintings were lying to us, we actually have more detail about this than they would have had otherwise, which is really neat. They think that the habitat change at the end of the Pleistocene as forests were changing, there were more forests and humans hunting it, and just the fact that you need a lot of nutrients to support these giant antlers might have led to its extinction. And there's a whole eons about this big old deer. Did Anne here? I don't know if Anne was here. This is Anne's. The Mammuthus primigenius, otherwise known as the woolly mammoth. So there are many other mammoths, not just one mammoth, but the woolly mammoth is definitely the one that everybody knows, most famous. And it mostly lived from 400,000 to 10,500 years ago. But some population survived, including a population that remained on Wrangel Island till 3,700 years ago, which those of us who played Amanda's Trivia know means that there were mammoths around the time they made the Great Pyramids. There were still mammoths walking around.
Where is Wrangel Island?
Wrangel Island is up, it's in the Arctic Circle. It's a
You
tiny
can't
little
lock that
island.
thing down.
Yeah, I don't exactly know where, but I think it's in.
How did they survive up there? What did they eat?
They were eating what else they did. I mean, there's probably weren't a lot of them, but they were up there still on Wrangel Island. Yeah.
Eating one another.
No, they would not mammoths. I like this painting, by the way, because this is like a thing that modern elephants do, where they like cry over the dead ones, and they have the mammoths doing that. And we know, I mean, this is obvious, but we know a lot about them because we find frozen mammoths and we can like actually see what they look like. And they did find one frozen baby that actually still had its mother's milk in its stomach when they found it. It's like it's really sad. And there's a whole eons about mammoths in general, but they definitely talk about woolly mammoths too. Now, I messed up my formatting, but we're going to talk about Diabolotherium. And one more sloth, which is a sloth that was not as big as the giant ground sloths, but this one could climb and lived up in the mountains. And there were also big sloths that made giant tunnels. There were sloths living on Caribbean islands until recently, 4,200 years ago. And there were some sloths, because of that interchange, that made it all the way up to Alaska. So there were actually all kinds of crazy sloths all over the place. Big old ground sloths. And we did this last time, but there was an ice age extinction. Was it overkill? Did humans kill all these animals off? Was it overchill? Was it climate change that killed them all off? Was it overill? Was it a disease that killed them all off? Or was it maybe another impact that possibly hit?
I'm distinctly disappointed you didn't have an over for that last one there.
Over, I don't have one for that. I have to think of one. And maybe it was a combination of several of these things. But here is our Cenozoic with all the creatures we went through. If you're curious, if you want, you can look and see where your creature was, but we got them all in here. And I have the ones in from last year too. So you can kind of see where all these things lived. It's not entirely to scale, but I did my best to kind of at least make it loosely to scale. Not scale, but like big ones look big, small ones look small. And
then the turtles are just the entire time.
There's just a bunch of turtles.
Turtles are just hanging out.
That's what I learned from last time.
Yeah, turtles just hanging out through time. Turtles in time.
Oh, great game.
All right, so here's the Holocene. This is the last epoch. 11,700 years to now. We all know what happens in the Holocene. There's a very stable climate that has allowed humans to flourish. But wait, what about the Anthropocene? Who here has heard people talk about the Anthropocene? Has anybody heard about the Anthropocene?
I mean, I'm a John Green fan, so yes.
Yes, definitely. All the time.
All the time. So I think the jury is still out on the Anthropocene. I think that to say that we're entering a new epoch is kind of crazy, considering that it was only 11,700 years ago that the Holocene started.
How were they dropping nukes 11,700 years ago?
They're not, but people debate. The thing is, they keep debating when the Anthropocene starts. Some people want to say, oh, once the nukes started, now we're in the Anthropocene. Some people are like, no, it's the Industrial Evolution. Some people are like,
You're showing us a nuke right now.
Is an example, Brian.
You're a terrible scientist.
Well, so are people who think the Anthropocene.
Is this an honest presentation, or are you stretching the facts? What do we trust?
It's true.
We're stressed out and we need to take a test. What's going on here?
Anyway, my point is that some people like to say we're entering this new age of the Anthropocene, and I'm
era.
I think if we are entering a new age of the Anthropocene, I think it's real bad news, because that means it's going to last for a long time, and we got to figure our shit out and make sure that things don't happen. There's also even people who say the Holocene is still just part of the Pleistocene. So there's a whole bunch of debate about what's happening now, whatever. But it's a thing that deserves mentioning, is that some people are like, we're in the Anthropocene now. And it's like, what does that mean? I don't know.
Joking aside, what is the Anthropocene?
The Anthropocene is basically saying that humans have created such an impact on the planet that we are now entering a new age, a new epoch. And I feel like hopefully, if it is anything, it's not going to be an epoch. It will be one of those little ages, one of those little smaller pieces, because it's not great. We got to fix our stuff. But I also think it's a little egotistical to just think after 11,700 years, which is a blink in the eye, that we're suddenly entering a new age. That's my own thoughts, though. It's a whole debate people can have. I think it's an interesting debate. But either way, though, we are probably entering some kind of a mass extinction because of what we're doing to the planet. So it's time to eat some more gummies.
And wow, Dan. What an ending.
This is my own little thing, which is to watch Cosmos, because Cosmos deep time stuff is really, really well explained on Cosmos. And I gave you a little episode list, but this will be in the post thing. But Cosmos is really cool if you want to kind of learn a little bit more.
Are you fucking done?
Yeah.
You can't end like that.
Is this or Neil deGrasse Tyson?
Well, actually, I have one episode from Sagan, and then I have the rest from Neil deGrasse Tyson.
Cosmos? What is this?
I did not work for Cosmos. I wish. And thank you for indulging me.
Dan!
That is it.
Dan, that was an hour 50.
Dan, I have to say that I literally pulled the GIF of this exact thing, and I was about to send it to the chat right now. But
Dan, that was like less than 2 hours.
I know.
I went fast. That's it. It's only 9 o'clock, man. I was so impressed. That was so fast.
Wait, Dan. What about the parts that we do have to worry about?
Yeah. Why are we worrying about?
What you have to worry about, Max, is the answer.
What's going to be on the test?
The answer is
I'm quiz?
Yeah. Hold on. I'm gonna get you guys. Thank you very much for coming. Thank you for indulging my.
Dan.
Wait. I'm gonna get another drink. I'll be right back.